All right, this one here, this section here, we are graphing these equations, and we're going to sketch the asymptotes and graph each equation. So this is the whole y equals k, y equals a over x minus h plus k. There we go. So that's the a, x minus h. The h is left and right, the k is up and down. So the a squishes or stretches it away from the origin. So since it's 3, it's going to be stretched a little bit farther away from the origin. So the h is 1, so it's one space to the right. So here's my one space to the right, it's right here. And then k is 2, so it's up 2. So 1, 2. Alright, so those are the horizontal and vertical asymptotes. Now I'm going to put numbers on each side of the vertical asymptote to tell what's going on here. So my first point that I'm going to put in is 2. So if I put 2 in, what do I get back? Well, if I put 2 in, I should get 5 back, because that would be 1, that would be 3, 2 is 5, so 2, 5. So over 2, 1, 2, up 5, 1, 2, 3, 4, 5. Okay, then another good point to put in would be 3. If I put 3 in, I get back 3.5. So I go over 1, 2, 3, up 3.5. 1, 2, 3.5. So it curves like this in this space. And it doesn't cross the horizontal or vertical asymptotes. Then the next point I'm going to put in is 0. So I'm going to put in 0 for x, because that's over here on this side of the vertical asymptote. So put in 0, that's going to give me negative 3 plus 2 is negative 1. So 0, negative 1. The 0, negative 1's right there. And then I'm going to put in negative 1, which gives me a half. So negative 1 over down a half would be right here. And so it's going to curve. Oh, it's up a half. Negative 1 is up a half. It's right there instead. So it's going to curve like so. So it's negative 1 up a half, not down a half. So it curves like here and here. Okay, the next one is going to be flipped upside down because of the negative 4 right here. And it's going to be 2 and 2. So it's 2 spaces to the right. So 1, 2 is right here. That's the vert. And then down 2. 1, 2. Okay, so there's the two boundaries. And then it's going to be flipped upside down. So it's going to be here and here. But it's going to be stretched out away from the x-axis. Or from this new origin here. Not the x-axis, but the new origin. Okay, I'm going to put in 3 into the equation. So put in 3. So 3 would go in, be negative 4 minus 2 would be negative 6. So 3, negative 6 is my point. 1, 2, 3, and then down 1, 2, 3, 4, 5, 6. And then 4 would give me negative 4. So I go over 4, 1, 2, 3, 4, 1, 2, 3, 4. Like so, and it's going to curve like this. So when I put in 4, I get 2, and then that'd be negative 2 minus 2 would be negative 4. And then some more points over here. I'm picking points on each side of the vertical asymptote is what I'm doing. So the next point I'm going to put in is 1. 1 would give me 2, and 0 would give me 0. So like 0 would go in here, and it would be negative 4 over negative 2, which is positive 2 minus 2 is 0. So it goes through 0, 0, which is the origin, and 1, 2, which is here, so it curves like so. And these are sketches. We're not like making a perfect graph. We're making a sketch of it. Okay, the next one doesn't shift up or down any. It just shifts over to the right. But it has 0, 0, or not 0, but the x-axis or y equals 0 is this asymptote. And then 5 spaces over to the right. 1, 2, 3, 4, 5. Okay, and then I plug in 6 for x. So I plug in 6. 6 would give me 1, so it'd give me 2. So 6, 2, 1, 2. And it should stuck in this space right there. And then 4, negative 2. Another one. So I pick on each points on each side of the vertical asymptote. So 1, 2, 3, 4, 1, 2. And it's going to be stuck in this quadrant right there. Alright, now this one is probably the simplest. No flipping over like this one. It's just going to be in the normal quadrants. So it's one space to the right. All of them were to the right, huh? I should have mixed it up and made some to the left. And then one space down. And then it's going to go through this point. And this point right there. And what are those points? Those points are 2, 0. So if you put 2 in, you get 0 back. And then the other point is 0, negative 2. So there's 0, negative 2, and it goes through there. That one, I know that one really well because it's just like 1 over x. It's going to go through those points that are one space away from the origin. But you can pick points, right? Put them in, get numbers back, and see how it curves. So all of these are kind of the same. Okay, the next page is an application, and it's talking about pitch. So the length of a pipe is inversely proportional to the pitch L in hertz. So the inverse variation is modeled by P equals 495 over L. So so the longer the pipe, the lower the pitch, and the shorter the pipe, the higher the pitch. And so it's inversely related. All right, so the L is in feet, and P is in pitch. The P is in feet for the pipe, the length of the pipe, and L is in hertz. Okay, so we have 220 hertz. So pause it here for a second. All right, I'm unpausing back. It's after school, and it's Friday afternoon, and I'm tired, and I just really locked my brain up. I had a major brain fart moment here. Okay, but I paused it, and I got myself all deflagellated, and I'm back ready to go. Okay, so we have this equation here. This hertz is the L, right? So it says pitch L. So this is my L right here. So we say the length of pipe P is equal to 495 over 220. So we divide those two on the calculator or whatever, and we get 2.5 feet. The next one says what pitch, so that's the L, because L, the pitch L in hertz. So what pitch would be produced by a pipe that is 1.2 feet. So we have, that's the P over here, so 1.2 is equal to 495 over L, which is the hertz. Think of this as a proportion, right? So you can do this times this divided by this. So L is really equal to 495 over 1.2, which would be equal to, divided on the calculator, 412.5 hertz. Then the same question is again, 0.6 is equal to 495 over L, because it wants to know a length of this much, that many hertz, and then L is or this many hertz L. And then again, think of this as a proportion. This times this divided by that. L is equal to 825 hertz. And then the last one here is a 3-foot pipe. So P is your length in feet. So 3 is equal to 495 over L to find the hertz. Let's find the pitch. So L's the pitch, right? Because it says pitch L in hertz. And again, think of it as a proportion. It's this times this divided by that. So it's going to be L is 495 divided by 3. And that divided by 3 evenly, 165 hertz. Okay, got it all straight in my brain. We're good.